Okay. Yeah, thank you very much. And thanks to the organizers for inviting me. It's really exciting to be the first speaker on the first day of the first generalization workshop. I thought this is also kind of an important topic to highlight given the times we are in. So, okay, what is it? This is a position talk rather than a talk in which I present you with a bunch of empirical research from my group. It's based on this position paper that we wrote with Sasha Lucioni. And I'm going to talk about why we need to talk about emergent properties. What do we mean by that? What evidence do we have of their existence, and what methodology do we need to solve the matter one way or the other? But before I give you what I think on this matter, I'd like to know what you think. So could you go to here and say whether you agree with that statement? This is very interesting because I asked 3 different audiences about this and I got pretty different distributions. Okay. Now, hold on to that thought. And what do you think that most people in NLP think about this? Do you think that most people think that they exist, or most people think they don't exist, or most people are unsure? Okay, so we have a consensus that emergent properties exist, and most people think that they exist. Okay, now, okay, we have about 50 people, so let's wait a bit more. Okay, a very clear message that most people think that they exist. Okay, now, however you answered these questions, what did you mean by emergent properties? So the first option is something that was learned without explicit training, something that was learned in general, something that was learned by only big models, something appearing unexpectedly during training, or something else. However you answered those 2 first questions, what did you mean? Okay, so we have the dominant sense that it's something that was learned without explicit training. And the second most popular sense is something that appeared sharply or unexpectedly during training. Okay. Now, on the off chance that anybody has a radically different definition of what this is, could you just put this in so we can see? Anybody understanding what emergent properties are in some completely different sense? I think a few people said other. Okay, so something that was not trained for and appeared unexpectedly. Okay. I guess that's these are our options. Only in big models and unexpected. Okay. Okay, thank you. So, okay, now why am I asking all this, and why am I giving this talk? You may have seen that unfortunate episode with Palm emergently acquiring the knowledge of Bangla, which it didn't. But the point is that this is kind of the narrative that we often see even in mainstream media now, that language models are learning something that they're not supposed to, and this is dangerous. And hence, this was the framing in the GPT-4 model card: risky emergent behavior, something that was unexpected. And then we have headlines like this. Also, if you just look for emergent properties on Google Scholar, you will probably come away with the impression that every concept that you can think of has been found as an emergent property. And this actually matters, because this is an actual US senator who actually went on Twitter saying that ChatGPT taught itself chemistry. And this is Melanie Mitchell, who had to go on Twitter and tell him otherwise. So, yeah, I think this framing matters because the wrong people might interpret things more seriously than they should. And the point of this talk is basically just me thinking aloud and trying to figure out, when we say emergent properties, what are we even talking about? And what do we actually know about them? So let's start with the definitions. I've gone through literature and I found 4 senses, which is the ones that I showed you. And the first sense, such as the one they used in the opportunities and risks of foundation models, is something that was learned without being explicitly trained for it. Okay, fair enough. The second sense is something that was just learned. So, for example, this paper discusses the advantages of pre-training as an emergent property. The third sense I found is that something that appears with an increase in model size, something that is not present in smaller models but present in larger ones. And this is the kind of graphs that come to mind when you think of that definition. And the fourth criteria is that they appear sharply and unpredictably, and that's the defining factor. So, okay, let's just go one by one. According to definition 2, this was something that learned during the training process, in which case, can we just say machine learning and not mislead any senators? Okay, as for definition 3, it's something that appears with the increase in model size. So it's not present in smaller models, but it is present in larger models. For example, one counterpoint here is that few-shot reasoning was shown to be possible in smaller models, and probably most of the tasks that you can think of are to some degree, and with a lot of dancing, possible in smaller models as well. Now, you could say rightly, okay, you have to do a lot of dancing to do that, but as I will discuss later, you do have to dance with the larger models too. And also, if we make the definition conditioned on the small and big, we have to say what the small and big are. And that's kind of slippery. So according to this paper by Jason Wei, the word and context benchmark was not solved by GPT-3. So GPT-3 was too small for it. It seems to be a model is small whenever it cannot do something. As soon as it can do something, it's big. And also, if we just look at these graphs, do we actually have enough data points to say that something is sharp or not sharp? We basically have 1 billion, 40 billion, 70 billion, and then 100. And like we don't actually, we can't actually say that something appeared sharp when we have that few data points. Okay, and one more, I think, hole in the definition 3 is its complete lack of acknowledging the role of the training data. So here are some of the emergent properties that Jason Wei lists for GPT-3. IPA transliteration, logical deduction, misconceptions, physical intuition. This really brings me back to this paper, AI and everything in the whole wild world benchmark. But okay, for Lambda, for example, one of the emergent properties is Swahili English proverbs. There's no way this is unrelated to the training data, right? And it's purely dependent on the model size. Okay, now definition 4. The sharpness transitioning seemingly instantaneously from not present to present. I do not have time to go into much detail on this, but I refer to you to this excellent paper by Schaefer et al., who are arguing that this sharpness is basically an artifact of the evaluation. And then we are left with the first definition. So by emergent property, we mean something that was that is happening, but there was no explicit training for that. And this is my position for which I am giving the talk. We actually cannot show this without analysis of pre-training data. And that analysis has not happened. Even for open models, we don't even have the methodology so far to say that we have analyzed all the supporting evidence beyond the obvious memorization. And of course, for closed models, this is completely out of the question. What we can say here, one possible twist on this definition that we got from anonymous reviewers is that, okay, a model that, this is a property that a model exhibits, although the model developers didn't know that they explicitly trained for it. And this is an interesting epistemic stance, but then, okay, after ChatGPT came out, there was lots of discussion of how it could play chess. And some people consider this an emergent property. Okay, it can play chess badly, but this is exactly what you would expect a language model to do as long as it was trained on sequences of chess moves, right? It will generate something that looks like chess moves, bad ones. And this is nothing new. I remember Word2Vec was able to put French words together in its news pre-training, Google News pre-training data. So, okay, it seems like what we have actually discovered here is that internet contains just data. And training an LLM to do that is a rather expensive way to, to come to that conclusion. Okay, so what evidence do we actually have that language models have these emergent properties? So the first emergent property, as far as I know, that was claimed is this few-shot reasoning in GPT-3. And you all remember the paper. One of the examples was the translation of English to French, word by word. You give it a few examples, and then it is able to continue on its own. And they experimented with different sizes, and they showed that large models are doing better. Okay, good so far. But then immediately people started finding that the order of the prompts and the framing of the prompts matters, and matters a lot. This fantastically ordered prompts paper, I think, is really a good framing for this. What it seems to be down to is that it's not actually few-shot learning, but it's many-shot learning, because usually there's a lot of held-out data that is used to find the optimal prompt. And in true few-shot learning setting, the performance is much less impressive. So if you haven't seen this paper, True Few-Shot Learning with Language Models, I highly recommend it. And this is why I say that when we say, okay, small models can do few-shot learning, but with a lot of dancing, so it's not fair, you have to dance here too. One more confounding variable in the models that we currently evaluate is the instruction tuning. So we don't actually look at the plain LLM. We currently most often look at something that also had fine-tuning on instruction data. And then, of course, the confounding variable is, does it follow this prompt, this specific prompt, because it was tuned to follow this specific prompt. Okay, so how well would LLMs work without these two variables? How would they work without few-shot learning, and how well would they work without instruction tuning? And luckily for me, here's a big paper from Irina Gurevich's group with over 1,000 experiments that just asked exactly this question. So they looked at a bunch of different open models and evaluated them on a bunch of tasks in basically the plainest setting possible. So, for example, for closed choice question answering, this is the kind of prompt that I would give to the model. And the models are plain, without instruction tuning, without few-shot learning. And as you can guess, they come to the conclusion that all of those 137 claimed emergent properties are down to few-shot learning, and instruction tuning does not cause anything independently, but just improves the few-shot learning when stars align. So this brings us to question the 137 emergent properties that were claimed by Jason Wei, including the Swahili English proverbs. Okay, so what is the possible interpretation of this finding? We can say that If a language model fails to answer correctly a prompt that wouldn't pose a challenge to a competent human, then we can either say that it's because we didn't ask nicely, or it's because the model doesn't have the requisite functionality. And here too, I'd like to know what you think. Okay, so I guess we have a slight majority for the people who believe in prompt engineering. Okay. Okay. Now, okay, so what is my position on this matter? Well, I'm on record in this paper, Machine Reading Fast and Slow, When Do Models Understand Language? Sagnik, are you in the room? The first author should be here somewhere. Anyway, so we actually propose a definition for when we can say that a machine reading comprehension system in particular can be said that it has a particular skill. So we would say that it has that skill if it can identify the target information, if it can do so by relying on the right information, by using the right reasoning strategy, and if it can do so consistently under distribution shifts that would not pose a challenge to a competent human speaker. So this was our definition like a year ago, and I still stand by it. One response that I got from the prompt engineers is that, okay, what about human variation? You don't, you can ask the same question to different people and get different answers as well. So what's wrong with the models for doing the same? I would argue that this is qualitatively different because, yes, we also can give different answers depending on our tiredness, motivation, and level of knowledge, and Dunning-Kruger syndrome. But we are in this business, we're doing NLP to build systems which are useful to us humans. And how much prompt sensitivity and what kinds would you tolerate from a human assistant? Arguably, this should be the goal. So if a slight change in the prompt breaks a model where you would not expect such a change to break your, I don't know, student assistant, then this is a no-no, in my opinion. Okay, so I think Irina Gurevich's group's paper dealt with most of the claimed emergent properties of the specific kinds. But what about in context learning? This was the emergent property number 1. Here I would point to this paper, data distributional properties drive emergent in context learning in transformers. So it is not actually a paper that is on natural language data, and we don't have conclusive evidence either way so far, but I think this is one of the steps to answer this question. So what they did in this paper is they pre-trained an autoregressive transformer to say on sequences like this. So there's a character, then it's code, then a character, then it's code, etc., etc. And they had 2 conditions: either uniform distribution of those possible characters, or what they called bursty sequences. So sequences in which the same 2 characters were occurring in clusters. And what they did after that is they evaluated on predicting the label for this character either in a uniform sequence or in this, again, clustered sequence with all the characters here being out of distribution, so they were not observed during training. And here they were only 1 and 0 to predict. And this was supposed to evaluate the in-context learning, and this was supposed to evaluate the in-weights learning. Okay, so what they found is, and the point of the paper was that as compared to meta-learning, neither the models the transformer architecture nor its learning objective explicitly train for in-context learning. So you could say that this is an emergent property in this sense. But basically, their conclusion is that this in context learning, it only occurs if you have those bursty sequences in the training data. So, and moreover, you also have to have a long tail of rare tokens, which rings a bell. And you also it also helps the training if you have those polysemous tokens, which also rings a bell. Yes, it's not conclusive. It's not on natural language data, but I think it's an interesting piece of evidence to consider when we think of the idea that in context learning just emerges. Their own conclusion is to say that yes, it is an emergent property, but I think we need to distinguish between two basically claims here. And one is that in context learning works on tokens and seen in training. So the model is able to take this new sequence of ones and zeros and predict the correct label correctly. And this is true. It can do that even if those two specific characters were not observed in the training data. So it is able to take new context into account, yes. What we do not know is that it would be able to do so if it was not habituated to this kind of structure during training. So this kind of structural generalization is that so far is unconfirmed hypothesis, I would say, with respect to in-context learning. Okay, so how do we figure this out? Let's go back to this GPT-3 example of English to French example of single translation of single words. When would you say that this is an emergent property? If the model did not observe any word lists, the model didn't observe any translated word lists, or no parallel text, English-French, or no French? What is your take here? Okay, this is also something that was consistently surprising to me. Again, I asked this to several groups of people, and I thought I was skeptical about emergent properties. Like, I would stop at bilingual glossaries, but it seems like most people are actually more strict, and they would require no parallel data. Okay. So that's quite high standard for us to say that something has an emergent property. And I would say that by that definition, we can't say that any model we have definitely has this property, because it most certainly has in parallel data. Okay, so yeah, done that. And as far as how do we solve this question, I think we have to look at the training data. And yes, this is completely ruled out for the closed models, which is the ones that are claiming sparks of intelligence. It shouldn't mean that they can claim any emergent properties that they like, just because we cannot look at the training data. One methodology that was proposed to rule that out was the one in the Sparks of Intelligence paper, Sparks of Artificial General Intelligence. So they proposed that to rule out memorization, they will construct new and complex training test cases. They will modify the code and ask GPT-4 to fix it or improve it. And I would argue that this methodology has not worked. One example is this. Probably everybody has seen that figure with the emergent unicorns. And this looks very impressive until you know that, yes, actually there is a community which was probably in the training data, which for fun draws ducks in in ticks. Now, are unicorns still impressive? Yes. Do they now look as an emergent property? No. Also, that was one of their conclusions with the methodology that they had. If you haven't seen this paper, I highly recommend it. I think theory of mind is ruled out very convincingly. So we must look to the data. And the good news is that it's getting easier to do so. So we developed during Big Science Project one of the first tools to explore the full training data of a large language model, and that's still online. So the full index of Bloom is searchable, and you can find out whether something was in the training data before evaluating. There's also now the C4 search, which got a lot better, and now returns also the number of matches by LNAI. So I hope this is the start of a good trend, and more open models will come with these kind of search indices, so we can actually figure out what is going on. My conclusions are, we need to be careful when we say the words emergent properties. What are we even talking about? If you'd like to use that term in the paper, by all means, but let's define what we mean. And let's consider what is the hard evidence for their existence under your definition. We can totally do research based on hypotheses and assumptions. We do all the time. We just need to state them as such. So thank you very much. That's what I have. And also, I'm looking for a postdoc.
Thank you so much, Anna. Right, I'll be leading the questions round for this one. Any questions for Anna so far? We only have one mic, so I'll be running around the room. Or if you can come closer to me, that would be great. Any brave?
There is one there.
Yeah.
Yeah, I'm just curious, what other populations have you given this talk to, and what are the different distributions that they have given you?
Yeah, so one was a research seminar in an NLP group, but a smaller and different sample. Yeah, that was okay. That was mostly on the side of questioning what's wrong with the prompt engineering. And I also gave this talk to a group of computational linguists. And yeah, that was, let me see if I... yeah, here a lot more were unsure what emergent properties even are. Not as many people know about them outside of our bubble as we think. And this was different. They agreed about something that was learned without explicit training. But here they predominantly were for, okay, if it fails, then it doesn't have that functionality. So this was maybe the sharpest difference. If it doesn't, if it fails on a very simple perturbation, it doesn't have that functionality, period. Oh, there's one.
It's really hard to see with the lights.
So I'm not sure how related this question is, but do you know if there's any research done if human learning itself has emergent properties?
Define what you mean.
So let's say a human learns task A and task B, and if there is anything that there's an emergent property or learning done, so they've learned A and B, and then now they can do task C, which was not related.
So like task transfer. I guess, but I guess that's the kind of the point of training that we give to children. They need to be able to count strawberries in a textbook, and then they need to count other things elsewhere, right? So at least context generalization is always supposed to be happening. Can you give an example of what you mean? Like what is task C that could happen here?
Well, I don't really have any examples, just thinking, why even talk about emergent properties in learning if humans even don't really have this kind of thing?
That's a very good question.
Yeah.
I guess we I don't know, is there some such a thing as like general improvement in reasoning capacity, maturity, which we definitely exhibit hopefully during our course of learning, but that's that seems to be a lot more than about this is a lot more than just the tasks that we have in the textbooks.
Thank you.
Hi, thank you for a very interesting talk. So I was wondering, I think I recently saw a paper also proclaiming emergent abilities in large language models, and I couldn't find the paper. Now I searched for it, but it was essentially about that the model learned how to sort of locate itself, like form a map of some kind of spatial environment. Like you had prompts to sort of tell it where it could go, and then it shows where to go, and then you could sort of reproduce some kind of map of where the model had been. I'm not sure if people recognize this paper. Yeah, some people are nodding. I'm not sure if the model was trained for this, but I think there was some kind of proclamation of emergent abilities. I was wondering, do you have any take on this phenomena? Like,
is this the paper by Max Tegmark with the emergent map of the world inside the model?
I'm not sure if it was an emergent map of the world. Maybe I can't recall really. Sorry.
Okay, also, this is the one that I remember, so I can say about that. So again, let's think back to Word2Vec. And already in Word2Vec, for Word2Vec, there were papers proposing geographical evaluation. If we didn't think that it was emergent then, why do we think it now?
Yeah, I agree. Oh, I don't think that was the paper, but yeah, maybe I couldn't provide a good example, but yeah, I can maybe ask in the break or something.
But if okay, but as far as I think what that paper was driving at is okay, but it has the underlying map of the world, and so based on that map, it can provide new generalizations and, let's say, calculate distances between unseen points, right? And then the question is, can it do? If it does do that, then it should do so 100% reliably, right? Otherwise, it's not a measurement, and it doesn't. As far as I remember, that paper, the entire global south was missing. Thank you.
Thanks for that very interesting talk. Sort of inspiring to think about these things. I'm wondering about the topic that you brought up about sensitivity to distribution. So I'm thinking in particular the paper that was out recently by McCoy and colleagues called Embers of Autoregression, where they showed sensitivity to the data distribution in the ability of the model to do certain kind of emergent properties. The example that comes to mind is its ability to do ROT13. And they found that the models are very good at doing ROT13, a lot less good at doing ROT14. And so, you know, on the face of it, if one can do the one kind of task, you ought to be able to do the other. And obviously, it's a sensitivity to distribution of that material in the input data. So I'm wondering what you think about that. Is that an indictment of emergent behavior, or is it just that emergent behavior can coexist with sensitivity to data distribution?
Well, again, that sensitivity exists in humans and to some extent has to be tolerated, but it has to be, for it to be practically useful, it has to be the same kind of sensitivity. And to the extent that, yeah, actually, I'm not sure, like computers are supposed to be better at some things than us. And for example, converting between different encodings is definitely one of those things. So if it doesn't do that, then why do we need it? Oh, that's one. Yeah.
Oh, just in front of the light.
Hi, I really liked your talk, and broadly, I think your point is great. I was just wondering about one thing with regards to you were saying that like, you would expect like with regards to different levels of human competence that you would expect like a human assistant to perform to a certain level. But I was wanting to ask about the fact that I guess human assistants have access to like context beyond just language in terms of both background, but also like visual context, you know, things like that. And so are we like expecting a level of disambiguation capacity that is beyond even what humans can do if we are expecting models to be robust to prompt perturbations despite not having access to that sort of context.
Thank you. This is an excellent point. And yes, absolutely, there should be cases in which people are being unreasonable in their question formulation. I think one of the examples they had in the natural questions paper is, what age do I get the driving license? And where, right? So this is just an ill-formed question. But also everybody in this room, from their experience of interacting with things like Alexa, knows that they fail at questions which are reasonably well formulated. And I guess that's the frontier to which we aspire to get, as long as we have models of the kind that we do.
Thank you for the talk. I have a question about emergence outside of NLP. So I don't think NLP people invented the idea of emergent properties. So is there a legitimate science of emergence or a legitimate definition of emergence outside of NLP? I mean, to me, I think of physics maybe as the area where to go for that, but this is, outside my pay grade. But I'm wondering if we can kind of import some formalism from real people who have thought about this.
Yeah, physicists are one distribution that invariably comes up when I give this talk. And yes, they have their definition, and philosophers have things to say about this. Yes, I think the broad idea is that there's some qualitative change emerging from a quantitative change. This may very well be in principle attainable. I'm not saying that it's impossible to ever get emergent properties in NLP systems. I'm just saying that at the moment we don't have good evidence that we have it.
Thank you for your presentation. So my question is regarding the emergent behavior or the emergent properties. Can you consider the emergent behavior as an abstraction for the, let's say, the task that it learned? For example, let's say it learned how to add number 1 and number 2. It didn't memorize it. So an abstraction in this case would be it learned the addition operation instead of just memorizing adding the 2 numbers. Can we consider the emergent properties as an abstraction method or something? I don't know if you get my question.
I guess this is kind of what we have in this definition. Yeah, so it has to get to the right answer the right way. So it has to learn the right abstraction, in your case, the arithmetic. So yes, if this were to happen, then I'd say that.
Yeah. So if we can prove it as, if you can prove that the emergent behavior is an abstraction of the task, so let's say if we prove that it can solve that task, it means that this is a really emergent behavior.
If it's okay. Now, would any system that would work well under this definition, would I say that it has an emergent property? Yeah, good question. Okay, so let's go back to the point about generalization, right? So it has to rely on the right information. It has to work on the distribution shifts. If you gave all of this in your training data, then it's learned, right? It's not emergent. Now, if it does all that, but you did not explicitly train this, then yes.
Thank you.
Thank you for the talk. There was this slide where you summarize what we can take away as far as in-context learning goes from the paper where they do in-context versus in-weight with the image example. And I think you had two hypotheses, and you said one of which.
This one?
Yeah, exactly. I'm
okay.
looking at, okay, token level in context learning emerges is confirmed, but then structure level, we are not so sure. I guess then stretching from token to structure seems like a very good thing. But at the same time, how far do we go down this line? Because I think when you mention of sequences, even the sequences, let's say in context of languages, are coming from certain valid sequences that are possible. So it's really not over all possible sequences that we are not yet showing in training data, but there is some underlying distribution that is generating the valid sequences. So I am wondering, yes, it makes sense, but then what is the limit, or how do we fine tune to make it testable at a structure level then?
And that's why I'm saying that we don't yet have the methodology.
Yep.
Hi, Anna. Thank you for the very nice talk. So I wanted to go back to your original motivation. You were giving these examples of, essentially some communications where people who are not NLP experts were, yeah, exactly these slides, right? Like they were using this terminology of emergent properties. So I think I agree with you that based on examining the training data, I think it's not really right to call these emergent. But then I guess how should we be communicating what's happening these days? Because I guess I would say that even if things aren't emergent, it still seems to be the case that large models are better at taking what's in the training data and being able to make use of it. Whereas, I don't know, maybe a small model might not be able to do the unicorn thing, train on the same TXI data, but a large model might be.
Yeah, that's a very legit question, but okay, the result of we took a larger neural net and we applied it to larger data and we got better result is kind of what we have been publishing all this time, but this is the first time we started saying that, right? So if before we were satisfied with saying the new model beat all the benchmarks, what prevents us from saying the same thing again, right?
I guess the question is whether people could have the same logic that oh, the models are getting bigger and they're getting better, and they might come to some perhaps unjustified conclusions of where things are headed.
Models are getting bigger and models are getting better. But again, this is exactly what we've had for years, right?
Okay, yeah.
I don't know why this necessarily by itself would drive the existential risk. It hasn't. Only when we started talking about this.
Okay, that's fair. Thank you.
Thanks very much. And we might have time for one very quick final question.
Hi, that was a wonderful talk. I really liked it. So my question is in my work, I frequently frequently observe that some of these large language models are generalists as claimed. Specializing it to specific domains still requires some kind of fine tuning or maybe even distillation to a smaller model. To what extent does emergent properties encompass this ability to be specialists?
So the fact that we can take a model and from that point turn it into a different model, basically, well, that's machine learning, isn't it? That's that has been the idea all along. And we don't. I guess this falls under what I discussed as definition 2. Something happens after we specifically try to make it happen. That's the successful machine learning.
Thank you very much. This is a great concluding remark. Please join me in thanking Anna again.
Thank you.
Thank you.